So hello, welcome to your first practice problem day. General ideas, today I'm going to go through a bunch of problems, some of which are old exam problems, some of which aren't. The packet has already been posted online. Solutions are now posted online. Hopefully you got a chance to look at them, but I'm going to go through how to do them. Quick thing about how, before I get into how this works, for those of you watching live, for those of you watching on YouTube, ignore this. Um, Zoom recently got an ability to do closed captioning, which I thought might be useful for some of you. I'm gonna try turning it on for today, and then also keep putting it on maybe next class on Monday, and then I'll kind of do an anonymous survey on people's opinion of it. If you find it is annoying you, you can disable it on your screen so you don't see it. You can also move it around. You can also do a whole bunch of stuff. So in Zoom, you can get rid of it if you want. Um, I messed around with it. I'm hesitant to use it because it seems to mess up what I say a lot. The little "all" really kind of fucks me over with this. And I'm reading what it wrote, and it just said it foxed me. So that's cool. Um, so we'll see if I do it much, but I want to try it out because if it could help anyone, it's worth it. General idea though, on the right side of the screen, you can see the problems we're solving, and then on the upper left, I have the equations. These over here. Oh, that's not what I wanted. These over here are for kinematics in general, and these are for kinematics in free fall. They're really the same equations. I'm just plugging in A equals negative G and replacing my X's with Y's. General idea? Yeah, I want to solve problems. I'm probably going to do 25 minutes of it because I would normally do that in lecture. And hopefully these will help you for homework and exams. Any questions about procedural stuff before I get started? Okay. Oh, is that a question? Guess not. So the first question says, a fully loaded Boeing 747 with all its engines at full thrust accelerates at 2.6 meters per second squared. Okay, let's just start writing shit down. Its minimum takeoff speed is 70 meters per second. How much time would the plane reach to reach its takeoff speed if it starts at rest? So we want to go from here, where we're not moving, at rest. At rest means our initial velocity is 0, to a max speed of 70 meters per second. And the question asks, how much time will it take? And part B is what minimum length of runway is needed. So that's going to say what distance it moves. Now, when dealing with X, not for Y, but when dealing with X, you can always say X naught is 0. And I'm going to say, okay, that is what I know. The plane starts at rest at this initial position, accelerates at that rate up to that speed. How long does it take? How far does it move? Oh, dude. You know what? Never mind. I don't even let people vote on it. I'm not using these transcripts. I just looked at it and it's just like, that is not what I said. And I think it would only be more confusing for people if I start having two different versions of it. And it's hard enough to understand me sometimes. So, you know what? You're dying. Sorry, I tried. Okay, so this is what we got. So what I'm going to do is I'm going to just collect my knowns and unknowns. I know V naught, I know X, I know V, I want T. And I'll play the matching game to my equations. This top equation has an X in it. I don't know X. And since I don't know X, and it's right here, I probably can't use that equation. Same issue with the bottom equation. But the middle one has only terms I know except for T. And so I know I have to use that equation because that's the only one that matches. If I try to use the top or bottom, I won't be able to solve due to the fact I don't know X. And so once again, this is how you pick your equations. I skipped this part. I'm using the equations on the left and not the equations on the right, only because this is an X. It's horizontal. If it's horizontal, I use the horizontal ones. and say, okay, it has to be that equation. That's the only kinematic equation I can use. And so I'll write that down. I like to plug in my zeros from the get-go. And I want to solve for time. So I'll just divide both sides by a. And I'll get that time is velocity over acceleration. Or 70 meters per second divided by 2.6 meters per second squared. And that'll give me an answer. For sig fig reasons, this will round to 27 seconds. Any questions there? Right. I think about these problems in general. You will find on Vanco Hall a typed version of this solution. So, if you can't follow my handwriting, it is typed. Oops, didn't mean to be drawing. So feel free to download that too. Now, part B says solve for x. So now we know this time. If I want to solve for x, I'll go back to my equations. And I'll say, which equation do I want to use? Well, this top one looks nice and simple. This top one says x equals. And I know x naught, I know v naught, I know t, I know a, I still know t. I could also use the bottom one, but I have to rearrange that shit, so let's ignore it. And so I'll use the top equation because it says x equals, and I know everything. And so I'll just say x equals x naught plus v naught t plus 1/2 at squared. Plugging in my zeros, x naught is 0. V naught is also 0. And so 0 times t is 0. So I'm left with just 1/2 at squared. But the distance he moves will be 1/2 the acceleration times the time squared. And that gives you 944.193 meters, which rounding to sig figs is 940 meters. Note, when I plugged in this time, I didn't use the rounded 27. I used the full value. That is to help reduce errors. I highly recommend you do the same when you do problems. I'm going to put more lights on. Any questions, though? Does that make sense? Okay. So, if you look at this packet, the next problem is about a coin toss. This is an old exam problem. This problem was on an exam just like this once before. On your first exam, the first problem will be about free fall. What it means if I say it's about free fall, I mean it will be using these equations. That will be the answer. What your first exam, the first problem will be solved like this. Not mincing words on it. No one should be surprised here. But I'm going to kind of do it the same way. Now I already have my drawing. And it says, for the coin toss, at the beginning of a football game, a coin is flicked upwards at a speed of 7 meters per second. Okay, right there. It's flicked upwards at a speed of 7 meters per second. That means that's V naught. And it's done so from a height 1.5 meters above the ground. Now, I think I've said this before, but if not, I'm saying it now. In X, I always make X naught 0. In Y, it's usually easier to make the ground 0. To define my 0 point, there we go, as this is my 0 point. And that means if it starts 1.5 meters above the ground, that means y naught is 1.5 meters because that's the height it started at. Y will be height, v is velocity. And now normally when you watch a coin toss, Super Bowl just happens, so it's kind of fresh in my mind. They don't just like normal, I don't have a coin on me. Oh wait, I can get a coin. Normally with a coin toss, you don't just flip it up and like if you just do a coin toss, you flip it up, flip it back down into your hand. right? So like you just boop, boom. But like for football games, you always want to just flip it and then watch it fall and hit the ground. And so I'm saying that's what's happening. It's going from the person's hand up to the ground. You can't see the ground, but trust me, it landed on the ground. This, whatever this coin is, it's an Italian money from before they used euro. So that means the coin is going to start that 1.5 meters up, but it's going to land on the ground. And so y is 0. And it says, what is the coin's velocity when it hits the ground? And also, how long is the coin in the air? So I got my knowns and what I'm looking for. And let's start with finding v. Once again, I'll do my matching game and say, okay, I don't know v, I don't know t, but I'm looking for v. But at the moment, I don't know t. If I don't know t, there's a t in, oops, wrong one. There's a t in this equation. I can't use it because there's a t in it. There's a t in this equation. I can't use it because there's a t in it. And so I have to use the bottom equation. I have to use this one, oops, because it's the only one without a time in it. That's what I mean by matching. If you write down all your knowns and unknowns, you just look for what equation has the same symbols. If I go to explicitly, I just can go, okay, let's see. I keep pointing. I have a problem with pointing, and you can't tell when I point. If I go through explicitly, I say, okay, V naught, V naught. Why not? Why not? Why? Why? V, V. Eureka! Ignoring G, because we know G. G is 9.81 meters per second squared. G is always 9.81 meters per second squared. And so I know I have to use that equation. Now, some of you might be wondering why that equation has V sub y's. Instead of just V equals V naught minus 2G y minus y naught, it's V sub y equals V sub naught y. That's just because of where I stole that from. That's going to come into play next chapter. Next chapter, I'm always going to use V sub y so we can keep track of its V in y or x. We don't need to worry about it now. I should have grabbed that from a different spot so that didn't happen. That's on me. Like before, I'll plug in my zeros because I got a bunch of them. Oh, that's not true. I got one. V equals V naught minus 2G negative Y naught. I'll factor through that piece.
Really?
Yep. What's up? Is that a question? Okay, I assume that wasn't a question for me. What am I solving for? What is the coin's velocity when it hits the ground? I'm solving for V. Oh, shit, I didn't square things. Sorry, I had the equation written up there, but I forgot to mark my squared symbols. That is on me. And so what V is, well, is V squared equals V naught squared plus 2G Y naught. I'm just going to solve for V squared first because it's easier. And say V squared equals 7 meters per second squared plus 2 times G Y naught. And that gives me a value for V squared. V then is the square root of that. And I get a value of V. 8.85 meters per second. Any questions though? Does this make sense?
How did you get 78?
I just did that math. So 7's. Boop. Well, that's fun. Apparently the battery's dead in my calculator. Okay, we'll do it this way. I have to go get new. So that's just 7 squared plus 2 times 9.81 times 1.5. 78.4. Make sense?
So, because this is going down, don't you want to accept the negative root?
You are correct. And I was going to get I was seeing if anyone would notice. That is the one issue. Is all that math worked, but yeah, it's going down. And that can't be right then. Thank you for getting me. See, I did skip that step. And I'm happy someone got it. When you square root, it could be positive or negative. And this is going down. So the answer isn't 8.85. It's negative 8.85 meters per second. You got to keep track of direction. Now, if you're using, anytime you're using this equation right here, it will tell you if it's positive or negative correctly. You don't have to worry about it. But if you're instead using this equation, you're always going to need to keep track of that because a v squared could be either. And yeah, I ignored the fact that I just gave a positive number and said, cool, done, wash my hands, and then waited to see if anyone commented. So thank you for commenting. Because it's not immediately obvious, but it's something you're going to have to keep in mind. If I didn't, part B would have been near impossible. Oh, yeah, would have been impossible. Questions? Okay, let's look at part B. How long is the coin in the air? Now I'm solving for t. So now I'm going to look at my equations and pick one to solve for t. I chose to use the second one just because it's easier. And say Vy equals, V equals V naught minus GT. I'll subtract V naught from both sides. V minus V naught equals negative GT. And I'll divide both sides by negative G. T equals, am I still on the page? I am. V minus V naught over negative G. And therefore it's going to be my initial speed, 7 meters per second, minus V naught, negative 8.85 meters per second. Wait, how am I off by? Ignore that, I did it backwards. This was V, negative 8.85 meters per second. I misspoke. Minus V naught. V naught was 7 meters per second. Over G. Oh, negative G. Sorry. It's you're alone. As I write these out, I often miswrite things and have to fix them. It's hard to do them like this. But I can do that math. I get negative 8.85 minus 7, which is going to be negative 15.85. Negative 15.85 divided by negative 9.81 is 1.61 seconds. That's how long it's in the air. No tricks this time. There you go. Any questions? Okay. Let's do one last one. Well, maybe I might do two more. Let's do another one. We'll decide if I do one after or not. This next one is also an old exam problem. And it's about Lord of the Rings. Super spoilers for Lord of the Rings, but I mean, the book is really fucking old, and the movies, if you're going to go that route, is 20 years. So I don't really feel bad spoiling. Gollum jumps up to take the ring and a finger from the hobbit Frodo Baggins, who is standing on a ledge overlooking the volcano called Mount Doom. And what really happens, and I don't say this yet, but I'll get into it, is he jumps up, takes the finger / ring, and then falls down lower. What initial velocity does Gollum need to have a maximum height of 0.982 meters above the ledge? So I'm going to start defining my terms. What I'm going to do is I'm going to say right here, I'm going to say that's where he starts, and I'll make that the 0. I know probably the lava should be the 0, but I don't know how far away that is yet. And I say this maximum height, y, is 0.982 meters. And I'm looking for what is V naught. Now, I don't know enough to solve this. If I want to solve this problem, if I want to solve for V naught, okay, well, this equation is V naught, but needs time. The next equation needs time. The next equation needs V. But I know something else. There's one more fact I know, not even going into part B. What else do I know about the highest point? Anyone?
Its velocity is 0.
Yep. Whenever you throw something up or jump up or anything goes up, at the highest point, V equals 0. And I said I can't use the first and second equation because I know T, but I said I couldn't use the third equation because I didn't know V, but I do know V. V is 0. And so I'll say V I forgot how to write a squared right there. V squared equals V naught squared minus 2gy minus y naught. Or plugging in my zeros, 0 equals V naught squared minus 2gy. I will add 2gy to both sides. And you know what? I'll just square root it right away this time. And I get an equation for the velocity. Oh, I'm off the edge. That V naught is simply the square root of 2 times g times y, which I already forgot what it was. 0.982. Short, because Hobbit. There you go. That's how high I to jump. Assuming that gravity on Middle Earth is the same as gravity on regular Earth, although I did actually write that. I feel like having read the similarity, and it sounds like something Tolkien probably would have even worked out gravity on the planet at one point in time. Dear God, it's death. Part B. Part B says Golem grabs the ring and Fingal, and without slowing or stopping, misses the ledge and falls down into the lava below. It takes 6 seconds to hit the lava. What's his velocity when he does? See, what I'm doing here is I'm saying before I said my V final was this highest point. But that's not where I'm going to be looking anymore. I'm going to say my initials are still the same spot, but now that final spot I'm looking at, that doesn't show up well because red on red, is here, which happens 6 seconds later. Which, side note, I worked out the time once again by watching the movie and timing. And I say, okay, I want to know the velocity there. Well, play my matching game. I know y naught. I now know v naught. I have a value for it, so I'm just going to cross out my question mark. I know t, I want v. I do not know y. So I don't know y, so this equation's out. I don't know y, so this equation's out. But I have everything for this one. And his velocity will just be v naught minus gt. It'll just be 4.39 meters per second minus 9.81 meters per second squared times 6 seconds. Which when you do that math, you get negative 54.4 meters per second. Negative makes sense, he's going down. And it's big, which makes sense because he fell really fucking far into a thing of lava. Don't try this at home. Any questions? Okay. So, if we were in person, I would have spent the first 25 minutes of class giving you time to work on problems. Once again, I hope that you will try to look at them before these sections. And I would have only spent 25 minutes solving problems. We're now 25 minutes into class. And so what that means is that is the end of today's lecture. These practice problems days will always be half a lecture because I really want you to go and try the problems yourself on your own. There are more problems in this packet. If you would like to try the problems in the packet, do so. I recommend it. Problem 4 was once also on an exam, although it's a little more complicated than I put on an exam now. And almost always the last problem is a lot more complicated. Although in this case, it's not that much more complicated. Usually the last problem is going to hold. The solutions, though, all posted online. But otherwise, unless there's any questions, I'm going to stop here. And we'll pick up Monday with two-dimensional motion. So any questions before I sign off? Cool. Have a good day and see you Monday.